To look at quadratic equations and graphing them in this lesson. This is MT9LT1. We're going to look at this by looking at the McRib. If you had the McRib, I have had it once in a while. It's pretty good. It's not great, but it's pretty good. The whole idea is it's a rib sandwich with no bones in it. It was kind of sold like, because people like ribs. Okay, it came in 1982 when it was born. One of the first non-hamburger items McDonald's had. They probably had chicken at this time too, I think. Okay, and then what happened after some bad sales, it died. And McDonald's does that. Makes some food, and sometimes it doesn't work out, then they stop it. But then, have you had the McRib since 1984? Yeah, it came back. Yeah, I wish I could buy a sandwich for $1.69 yet. Whoops. We'll try that again. So what happened, it's died, but it's come back. It's been reincarnated a bunch of times since the early 90s, 92, 99, 2010. It came back a couple years ago in 2020. So, in fact, in 2005, they said they're going to permanently remove it, and it gets a farewell tour. Obviously, that was a sales ploy. And then, after a petition from the fake boneless pig farmers of America, I thought that was kind of funny, it gets another farewell tour in 2006. So it went on for a couple years. And in 2007, it was given a third farewell tour, and it sold about 30 million sandwiches. So, pretty good sales pitch. And it's inspired by many songs and headlines about what's good, what's not so good about it. It even has an online tracker. McRibLocator.com will tell you where you can buy it for sale throughout the world, I think. So we're going to look at, why is it only offered on a limited time basis? How come they keep killing it but keep on bringing it back? And so these are your guided notes. I want you to take some notes on this as we go through these. And we're going to look at quadratic equations, finding the vertex, and finding the ruts. Well, we're not going to spend so much time finding the ruts. That's later on. But we're going to do the first two a lot today. Okay, a quadratic equation is anything with the second power. It's a parabola shaped. Notice that the parabola is U-shaped. It could be a sad U like it is here. It could be a happy U. It could be skinny. It could be wide. But it's going to be U-shaped, which we call a parabola. Then key ingredient, you got to have the x squared term. You can't have other terms. You can have the x term. You can have numbers. But if you don't have the x squared term, it won't make a parabola. Okay? The standard form of a parabola, we're going to say ax squared plus bx plus c. We go from the biggest exponent to the smallest exponent. We've done kind of that before, but now we're looking at specifically at parabolas. And when we look here, my a on this one is -1. My b is also -1. And my c is 2. And then the a term, the term in front of x squared, tells you whether your parabola opens up or it opens down. Notice this parabola opens down because it's negative. So when it's sad, it's going to have a negative in front of it. Conversely, when it's happy, it'll open up. Now, your C term is going to be what your y-intercept, just like we've done y equals mx plus b, but now it's C. So what happens when x is 0, the a's and b's go away, left with C. Notice on this one, our C is 2, and it goes through 2 on our graph when we graph that out. Okay. So, like I said, we replace zeros with a and b, or for the x's, I'm sorry, but they make a and b go away because anything times 0 is 0. So when x equals 0, we get a y-intercept of 2. Now, revenue is how much you take in. Cost is how much you have to spend to produce that. Now, McDonald's doesn't own a bunch of boneless pigs, so they have to pay some money to get those. Your profit is going to be your revenue minus your cost. We've done that before. So even if you have high revenue, if your costs increase, you could lose money. So we got to be careful of that. So they must decide the number of days they're going to produce the McRib to maximize their profit. So our simple model is, we'll do a simple model. Let's say it costs $200,000 to produce the McRibs every day, and you make $400,000 each day in combined sales for the different types of sandwiches they have. Well, that's a pretty good model then, isn't it? So our revenue is $400,000. Our cost is $200,000 per day for X days. So to find our profit, we're going to take our revenue minus our cost. And notice, under this model, we're going to make $200,000 every day. Well, if that's the case, hopefully you're going to keep the McRib. So we can fill in our table here. One day, you make $200,000. 2 days, you make $400,000. 3 days, you make $600,000. 4 days, $800,000. And 5 days, you're going to make $1 million. So in this lesson, we're modeling the total profit. The sum of all the profits accumulated over time is our y variable. So if we graph this out, after 1 day we got 200,000, and then 2 days would be 400,000, 3 days 600,000, 4 days 800,000, 5 days $1 million. And then if this were a real model of profit, they would just keep going up and up and up. So they would probably keep it on the menu forever, wouldn't they? Because you can just make more profit. Rise and rise and rise again and to infinity and beyond. Now, that's our simple model. Okay. Now let's do a little bit more realistic. Here's a more realistic. We're going to take 400,000 times negative 0.01 x squared plus 0.5x. That's our model based on some statistics. We'll learn about that in Chapter 10, but that's our model for right now. So when we graph our model, notice what happens. Our profit increases, but then it starts to decrease because your cost could keep on increasing, or you get the novelty of this coming out, so people are going to try it, but they're not going to have it every single time. Okay, you go to McDonald's for a specific case, and a McRib is not probably one of those cases you're going to do it over and over again. But maybe you like it, maybe you will. Okay, so the negative 0.001 x squared term makes it a sad parabola. It's opening down, isn't it? So does this trend make sense? Hopefully it makes sense for what we talked about. Yes, it does. Okay, and it says when the sandwich is released and it grows, increasing fanfare, the novelty of a boneless rib sandwich. That's in 1982. So yeah, they sold a bunch. In 83, as the novelty wears off, the revenue declines and the profits start to slow down. Eventually, they only sell enough McRibs to even out with the cost of production, so they're no longer going to add it to their total profit in the whole. Remember, if you're in business, your whole idea is to make money, not to lose money. So, in 1984, the cost of bulk shipments of ingredients outgrows the sales. The loss eats into the profits, so they discontinue the McRib because they don't want to lose money. Few people are going to regularly get the McRib, like we said. You'll have it once or twice because it's a novelty, but then that novelty wears off and the costs begin to outpace the revenue. So how can I sell the McRib a lot and keep it profitable? Really, you release it rarely and randomly, so you don't know when they're going to release it, so it stays a novelty. So get your McRib while it lasts. So if they're going to release it, and it's only going to be for a short amount of time, you're going to probably go and buy it because you're interested in that. So every several years, it comes back to induce headlines and novelty buying. Like we said, 92, 99, 2010, 2020. Now we're going to look at finding the vertex of that model. So when McDonald's brings a McRib, how long should they do it for? Well, they want to maximize the profit, don't they? So we want to know, when is that total profit maximized? Well, first off, we're going to put it into standard form. So we're going to distribute that 400,000 inside the parentheses. So you take 400,000 times negative 0.01, you get negative 400 squared plus 200,000x. So in this problem, A is negative 400, B is 200,000, and C is 0. Because when you start, you're going to start with a profit of 0. And then I want to know, how long should they keep it out for? And we can kind of see in our graph where the maximum is right here. Okay, so here's the days in the menu. That's on your x-axis. And notice we start at 0. And it opens downwards. So a vertex, that's the tip of the parabola that you can't get any bigger than. It might be smaller, but it can't get any bigger than that since it's a negative one. If it was a happy parabola, that would be the minimum. So how can you find the number of days that maximize the total profit? Well, the axis of symmetry is going to divide my parabola in half into 2 reflected pieces. And it always passes through the vertex. That's another hint. It always passes through the vertex. So their axis of symmetry using A and B. Notice we don't have to use C because C is their y-intercept. It's the opposite of B over 2 times A. So the opposite, notice I didn't say negative B. If B is negative, then it would be positive. But it's the opposite of B over 2A. So we're going to substitute 200,000 for B and negative 400 for A. So we get negative 200,000 divided by 2 times negative 400. And then, so in other words, we take negative 200,000 divided by negative 800, and you get 250. Notice, after 250 days, that's going to be our maximum profit. Notice, it's a vertical line, so it's x equals. Don't just write 250. That's a point. The axis of symmetry is a line, so you're going to draw a line through x equals 250. And there we have that. Now, the maximum profit occurs 250 days on the menu. And notice, after 250 days, we're going to have about 25 million in profit. And we can find that algebraically also. So our maximum profit is y. So now what happens to find it algebraically? We said x is 250. So what I'm going to do is I'm going to replace x with 250. So I'm going to take negative 400 times 250 squared plus 200,000 times 250. And so when I do that, if I square, 250, I get 62,500. And then simplify that, we get negative 25 million plus 50 million. So our maximum profit we could see from the graph was 25 million, but algebraically would get us the exact answer. Okay, so McDonald's should release the McRib for 250 days and expect a return of about $25 million in profit. And there we have it. And let's